Welcome to How's That Work? And today my name is Mrs. Foster. Today we're going to go ahead and look at Newton's second law. Newton's second law is all about force equals mass times acceleration. And how does that work? How does the equations work? And how does that really apply to real life is what we are going to look at today. So remember from our last video, we went ahead and explained how the different mathematical equations for force equal mass times acceleration works. And we use this handy dandy triangle to show us. So whenever we don't know what we are looking for, you simply cover it up and it helps us remember what to do. So if we didn't know force, we're going to take acceleration times mass. If we didn't know acceleration, we'd take force divided by mass. If we didn't know mass, we'd cover it up and take force divided by acceleration. And that's what these three different formulas show us. And it's all based off of this formula right here. Again, I mentioned this and I go over this in my previous video. Go ahead and subscribe to my channel and check it out to see how I came up with each of those different equations. So we're going to go ahead and look at this real world example. Here we have a person shopping in a store. Their cart has 10 kilograms of stuff and it's moving at 2 meters per second, which is the same thing as meters per second squared. Now, I talked about this again in my last video, but meters per second is the unit for acceleration and kilograms is the unit for mass. So we have acceleration, we have mass, what we don't have is force. So what is the force that this person is pushing the cart? So we're going to take this formula, again, our triangle helped us figure it out, and figure out the force. So we're going to plug in those numbers, 10 kilograms for mass, 2 meters per second squared for the acceleration. And as we do that, we can see that 2 times 10 is 20. So the force is 20 kilograms per meters per second. Well, remember that that is the same thing as a Newton. So this cart is pushing with a force of 20 newtons. Now let's look at this next one. Here we have a person pushing a wheelbarrow. Here it says that it has 30 kilograms and it's moving at 5 meters per second. So again, we know that this is the mass, this is the acceleration by looking at the units. So we have acceleration and mass, so we're going to cover up force and notice that we have force equals mass times acceleration. We're going to plug those numbers in. So 30 kilograms times 5 meters per second squared. What's 30 times 5? That's right, it's 150. So we bring down the units and we have 150 kilograms times meter per second squared. Or remember, it's just easier to write that N because it's the same thing as a Newton. So this person is pushing with 150 newtons. Okay, so let's look at our next example. Here we have this raccoon lifting weights. So it says that it has 15 N or newtons and 3 meters per second squared. Now we have force, newtons, we have acceleration, meters per second squared. What we don't have is mass. So we're going to cover that up and write M equals, and then we have force divided by acceleration. So force divided by acceleration, we start to plug in these numbers. So we put M equals 15 N newtons over 3 meters per second squared. Now remember, newtons can be kilograms per meters per second squared as well. And we're going to go ahead and put that back in there now since we have meters per second squared on the bottom and meters per second squared on the top now. What that allows us to do is we're going to be able to cross those off. So whenever you have something above and below an equation, they basically both become 1, and 1 times itself is whatever they're times by. So basically we can just cancel them out and not worry about them since they both became a 1. Now that leaves us with 15 divided by 3 and the unit kilogram. So what's 15 divided by 3? That's right, it's 5. So we can find that the mass equals 5 kilograms. And we know we did things right because we ended up with the correct unit for mass. All right, looks like you're getting the hang of it. Let's go ahead and try another one. Here we have a guy walking carrying a backpack. He is walking at 10 meters per second squared, and the force he's exerting is 100 newtons. So again, the thing we don't know is the mass. How much is he carrying? How much is he weighing? And so we are going to take force, our 100 newtons, divided by acceleration. So let's plug those numbers into our equation now. So we have mass equals 100 newtons divided by 10 meters per second squared. Again, we're going to change the newtons back to kilograms times meters per second. And then we're going to go ahead and be able to cross off those meters per second squared. Now, the fun thing about this problem is that we have lots of zeros. So since our 100 has a 0 and our 10 has a 0, we can actually go ahead and cross off one of those at the end each, just to make the problem a little bit easier for ourselves. So now what we have is 10 kilograms divided by 1. Well, what's 10 divided by 1? It's 10. So we have 10 kilograms left. So the mass equals 10 kilograms. And again, we have the right unit, so we're pretty much sure we're on the right track. So well done there. Okay, so let's look at this one. Here we have a guy riding his bicycle, carrying his dog. We can see that there's 50 kilograms and 200 newtons. Now remember, newtons means force and kilograms means mass. So we have force and mass, but we don't have acceleration. So we're covering that up. A equals F divided by M. So now that we have our equation, we're going to go ahead and plug in those numbers. So A equals 200N divided by kilograms. Again, we're going to change the newtons to kilograms per meters per second squared since there's kilograms on the bottom. And the next thing we're going to do is cross off those kilograms. They cancel each other out. But again, this is a nice one that we have zeros on both the top and the bottom. So the next thing we're going to do to make this an easier problem for ourselves is cross off those zeros as well. So all those kind of cancel each other out. So now our problem is acceleration equals 20 meters per second squared divided by 5. So what's 20 divided by 5? That's right, it's 4. So our acceleration in this problem is 4 meters per second squared is how fast that person is riding their bicycle. Okay, now we have a person running. Running is great. There she goes. And she is exerting 30 newtons of force and her mass is 15 kilograms. All right, so we know our force, we know our mass. What we don't know is our acceleration. So we're going to write A equals, because we don't know what it is, force divided by mass. And the next step is to what? That's right, plug in those numbers. So here we're going to go ahead and plug in the 30 newtons divided by kilograms. Since we don't have any like units, we know that this can change. So we're going to go ahead and do that. So we're going to have acceleration equals 30 kilograms times meters per second divided by kilograms. The next thing we do is what? That's right. We're going to cross off those kilograms because they cancel each other out. That leaves us with acceleration equals 30 meters per second divided by 15. Do you know what 30 divided by 15 is? Did you say 2? Because that is the correct answer. So here we have 2, and the unit that we have left is meters per second or meters squared. And that is the correct unit for acceleration. So well done there. All right, that's how Newton's different equations for his second law works. I hope you had a great time understanding how that all fit together. And if you missed my video before this, make sure you click on this square here and check it out for even more understanding. Have a wonderful day.